Today we're going to be graphing cosecant and secant, and we're going to find out that these are incredibly easy to graph if you can graph sine and cosine. I do want you to add something as kind of a subtitle to graphing cosecant and secant, and it's very important. And it's just a way to remember how to graph them. We're going to add as a subtitle where the hills and valleys meet. And you're going to find that that is the key to graphing secant and cosecant, by remembering where the hills and the valleys meet. And you're going to see what I mean in just a minute. Well, let's just start refreshing our memory here. First, about cosecant. Cosecant, we said, is the reciprocal of sine. Okay? Cosecant is the same thing as 1 over sine. Now, as soon as you see that, that means that we have a denominator. As soon as I have a denominator, then I need to start thinking this thing could be undefined in certain places, which means there could be asymptotes again. So we need to ask, where is sine equal to 0? Because wherever sine is equal to 0, then the graph of cosecant is going to have asymptotes, just like when we dealt with tangent. So let's just draw a little quick sketch of sine. Let's just draw the parent function real quick. We know where those places are by now. If I do the parent function, it's equal to 0 here at 0. It's equal to 0 here at pi. It's equal to 0 at 2 pi. If I kept going with my graph, it would be equal to 0 at 3 pi. And if I came over to the left, I'm kind of out of room, but there would be another place over here at negative pi. Every one of those places, sine is equal to 0. All right? So that means for cosecant, every one of those places is going to have an asymptote. So we can kind of summarize it this way. Sine x is equal to 0 at negative pi, 0, pi, 2 pi, etc. And these are where we're going to have asymptotes. And the asymptotes will be, for the graph we're learning today, for cosecant. All right? Now, if we look at secant, so we kind of draw a line here. If I look at secant of x, secant is 1 over cosine. So we're going to do the same thing. We're going to try to figure out where is cosine equal to 0, because we'll have asymptotes. So let's think of our kind of parent cosine function. It does this, and it would keep going here to the left. And we know that it has zeros. Here's one at negative pi halves. Here's one at positive pi halves. Then 3 pi halves, 5 pi halves. I could come over here to negative 3 pi halves. All of those places, cosine is equal to 0. Cosine is equal to 0 here, 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 and every odd pi halves after that. All right? And we saw that that actually told us where the asymptotes for tangent were located, because tangent is sine over cosine. So we can kind of summarize here. We can say cosine is equal to 0 at negative pi halves, positive pi halves, 3 pi halves, etc. And these are where we will have asymptotes. The asymptotes That's the asymptotes for secant. All right? So, let's graph cosecant now. We are ready to graph it. And you're going to see it's very easy. If I want to graph cosecant of x, well, the first thing that I have to do is graph sine. This is what's going to make it very easy. Now, when we graph sine, let's kind of make it a dashed line because it's not really going to be on the graph. It's just helping us figure out where the graph of cosecant is at. All right, so there's a little bit of the sine graph. And we can put in our 0 locations. Here's, this would be negative pi. This is 0. This is pi. That's 2 pi. And that's 3 pi. Now, we just finished saying that at every one of those 0 locations, there's going to be an asymptote. So at every one of these spots, the graph of cosecant will have an asymptote. So we'll put in our asymptotes here real quick. And 90% of the graph is done now. Now we're going to use that subtitle. Cosecant and secant are where the hills and valleys meet. So watch how easy this happens now that we've got our asymptotes in there. I'm going to draw the graph of cosecant in kind of a pinkish color here. And I'm going to make the hills and the valleys meet. So there we go. There is the graph of cosecant in that pinkish color. And if you're wondering about these places where they meet, they really do meet there at 1. And they really do meet at -1. All right? So if you come back to your sine graph, let's think back to sine for a second. The sine of pi halves, isn't that equal to 1? Right? So if the sine of pi halves is equal to 1, since cosecant is 1 over the sine, then 1 over 1 is 1. All right? So at all of these locations where they meet, here, 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 and here, those values really are that 1, or down here it'd be -1. Now, what is 1 period of cosecant? Well, it's 1 hill and 1 valley. It's the same thing as sine. All right? Right here, from there to there is 1 period. So yes, it is 2 pi, just like sine, its partner or reciprocal function. The period of sine is 2 pi, so the period of cosecant is also 2 pi. All right? Now, let me ask you one more question. Is that dotted black graph really there? No. It's really not there, but it's okay by me if you sketch it in. But in reality, if I were looking at the cosecant graph, this dotted line would not be there. Okay? So in reality, it's just the pink part. Okay? So let's graph secant now, and you're going to see that secant operates the same way. Work in black here to start. Y equals secant of x. So here we're going to graph what first? Cosine. So here we'll graph cosine first. And again, use a dashed line. Because it's not really there. So we want to use a dashed line. The only thing this is doing is showing us where the zeros are and where the hills and valleys meet. Fill in your locations of your zeros. We know that this is pi halves. This is 3 pi halves. This is 5 pi halves. Over here, this would be negative pi halves and negative 3 pi halves. At all of those spots, cosine is equal to 0. So at all of those spots, I need an asymptote. So every one of these places, we're going to have an asymptote. All right? So draw in your asymptotes. These are places where secant is undefined because at every one of these spots, cosine is 0. So we put in an asymptote, and then just like before, we're going to make the hills and valleys meet. So we're going to make them meet at all of these 1s and negative 1s, just like before. They're kind of like little mini parabolas. Right side up and upside down. All right, so there's all that. There's a couple periods, I guess we could say, of secant. Now, what is one period of secant? Well, it's still 2 pi, but because cosine is shifted, it's in a different spot. From here to here, this would be 1 period. That would be 1 period of secant. All right, from negative pi halves to positive 3 pi halves. Because we want 1 hill. All right, here's our hill, and here's our valley. All right, so we want to go all the way from negative pi halves to positive 3 pi halves. Now, that's really as hard as it gets. The only thing you have to remember is that you've got to account for the shifts and changes in period that take place with sine and cosine. So I want to finish here with kind of a summary. Okay? This is kind of a step-by-step to make it easy. We'll make this kind of a bulleted list here. First bullet. All right? Let's say, let's call this the summary of graphing cosecant and secant. This will be kind of a step-by-step or bulleted how-to list. All right? First bullet is you have to graph either sine or cosine first. All right? And you must include, okay, you must account for changes in period or a shift, etc. Changes in amplitude. Okay, I could add amplitude to the list. Okay, you just graph sine or cosine just like you always would. All right? So I'll show you in just a minute. The period will change based on whether it changes for sine or cosine. Okay? So let's come back to that in just a second. Let me finish my list here. The next thing you need to do is use the x-intercepts or the zeros of sine or cosine as the asymptotes. Okay, so once you graph your sine or cosine graph, Wherever it crosses the x-axis, that's where there's going to be an asymptote. And then finally, make the hills and valleys meet. All right. Now, I'm not going to go all the way through another example, but I want to answer what I know is going to be one of your questions. Well, how does this work, the change in period or whatever? Let's just kind of start an example, and then I think the light bulb will come on. Let's say that I was asked to graph y equals, let's make this 2 cosecant. Y equals 2 cosecant of 2x minus pi, something like that. And I wanted to graph that. Well, all you have to do is first off remember that this is the same thing as 1 over 2 sine of 2x minus pi. Okay, that's the most important thing to remember, is that if you see that 2 cosecant of 2x minus pi, you just have to remember that it is related to sine. So what you're going to do is you are going to graph this just like you always would. You're going to start by, what is your amplitude? Your amplitude is 2. Your period, I need to factor out a 2. 2 times x minus pi halves. So my period would be, for this one, 2 pi divided by 2. It would be pi. Right? And then don't we have a shift? Right? So there's a shift right pi halves. So, and then wouldn't we need to find road markers? Right? I need to find road markers the same way. Road markers would be the period times 1/4. So my road markers are pi fourths. And then you would sketch a dashed line of your sine graph just like before. I guess I'm going pretty much all the way through this thing, but that's okay. So my road markers are at pi fourths. So there's 1 pi fourths, 2 pi fourths, 3 pi fourths, and pi. But it is shifted to the right pi halves. So I'm really going to start right here with my graph of sine. So I need a couple road markers. 5 pi fourths, 6 pi fourths. So my graph of sine, now let's see, my amplitude is 2. My graph of sine will be like this. I'm going to have dots there, 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 and there. Okay, and I could keep coming this way. And so all of these x-intercepts are going to be my asymptotes. So any place it hits the x-axis, I need an asymptote. There, 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 and there. And then you just make the hills and the valleys meet. That's why I said it's essentially just graphing sine. Okay? So once you find out where the hills and the valleys meet, then you just put those in. And there's my graph of cosecant in green. And I actually did about a period and a half. One period would have technically been this part right there. Okay? And we will stop there for today.